Hey Mustang Stampede, I'm out here checking out my Coyote outdoor wood stove. Right here is the thermostat. It's currently setting at 170. Alright, you look up here a little bit, you can see my gauge for adding water to the system. If it's in the red, I need to add water. There is one section of chimney pipe that I added to the stove itself. Alright. Right here in this box is a small Dayton blower motor. Receives its power from that conduit right there. So when there's a call for fire, that turns on, blows, forces air into the firebox. I put a bolt right here. Occasionally the draft, there's a flap door that goes up and down. Sometimes that would get stuck open if it was high wind, and it would allow the system to boil over because it constantly allowed fresh air to get into the firebox. So I added a bolt with a jam nut on both sides and screwed it into length to prevent that door from opening up any certain amount. I typically find that I'm getting 24 hours of burn time out of a yard cart of wood. That's a 10 cubic foot yard cart, and it's not stacked in there all neat or anything. It's just tossed in there, and sometimes I stack it in there and eat, and sometimes I don't, but typically that's what I get. I did pour a concrete porch for the stove, and I have the ability to stack 2 cords of wood, 4 foot wide, 8 feet long by 4 feet high, right beside the stove. It does have skids on the stove to be able to move. So you just put a strap down there, hook it up to a tractor and drag it wherever you want it to be, but this is a permanent, basically a permanent area for this stove. I won't ever change that. And again, I think I mentioned, if not, I do get about 24 hours of burn time out of a load up of wood. And again, it's heating like 220 gallons of water, and the pump goes 24/7, so there's never a need basically to clear the line of cold water, bring all that cold water back to the tank here and reheat it. So that helps with burn time. And you don't ever want to just open these up real fast. You don't want to get a backdraft now. This was just stoked by the fan a few minutes ago. You can see in there. Alright, I can fit one of those carts of wood in there. It was 60 something degrees today, so obviously there's a lot of leftover wood, and I had a couple chunks in my way earlier, so I threw them in there. Right there is the blowhole for the forced air to go into the firebox. Alright, so you got any questions on this, feel free to let me know. There is a fire rope around the door that seals up here. Ash wise, I've had this since 2014. I fired it up on November 1st, 2014. It's been burning non-stop since then, except for one occasion. When I let the fire die down, basically, now you can just see the flames reignite because there's a lot of oxygen in there. I let it burn out in the summer so I could get rid of the ash. I'm finding right now that, other than putting out some black ash on the driveway when it snows to melt some snow, I don't really need to empty the ashes out. So basically what happens is I'll empty the ashes out once this summer, and I'll just load them all up into my yard cart and go dump them in the garden. Makes great fertilizer known as fly ash. Alright, so the first moving part of this stove is that Dayton fan. One reason why I chose this stove was for a lack of moving parts that needed replaced. And I also chose it because those parts were relatively cheap. So the second moving part, if you want to call that, is the Aqua Stat. The Aqua Stat is adjustable. And what that does is when the water, it measures water temperature. And what happens is when the water drops below a certain temperature out here, those wires right there signal the fan out front to kick on. So then that fan stokes the fire. Alright. Inside, I'll show you. There's gray wire here. It's connected to a waterproof outlet, and that gray wire runs into the house. There's a junction box right here. That junction box has all the connections, and it also goes back out to the front of the stove to power that Dayton fan. Alright, then the third moving part is the Tako Pump or Tako Pump. Alright, this one is a Tako 0011 BF4-J, and basically it's on 24 hours a day, 7 days a week. Alright, so the hot water comes in right there, comes down through there, and goes all the way down and into the house. Right here, you move that, you can see the red. See the red pipe? That's going into the house. Alright, I've insulated that. Well, it come insulated, but I put the plastic around there and put some duct tape around it going into this black corrugated pipe that's buried in the ground and goes into the house. This one right, I'm trying to hold this flashlight, it's kind of difficult here. That might help some. This pipe right here is the return, and it goes up. And I've added some insulation to the back side of this because this is the only part that isn't insulated. It goes up to about, let's see here, very difficult to do. That return line somewhere about right here on the back side of this stove. You see. Alright, now on the other side here, somewhere in here, there's actually another place for a pump to go. So I have another return and another outlet, and I can hook another pump to this. It could be used to heat my garage, the house, and the swimming pool if I wanted to. Alright, so that's basically the outside. I'm going to put the panel back on, back side of the outdoor wood burner, and I'll show you the inside. As always, thanks for watching. Alright, I'm going over the inside portion of the Coyote outdoor wood burner. Here's the hole that I had to drill through the basement wall for the 4-inch corrugated pipe to come through. The corrugated pipe has no breaks or seams in it all the way out to the wood burner. Here's the 110 volt connection going out to power the outdoor wood burner. The red line is coming in from the wood burner. This water is usually around 155 degrees coming into the house. The blue line is the return line. This water is cooler depending on what we're using in the house. If we're using domestic hot water in the house, it's using the heat coming from the red line to heat the hot water, and then that takes the heat out of this incoming water and sends it back to the wood burner. Again, this is it's a closed loop system, so it's not being used by our domestic hot water, but we're using this water in here to heat our domestic hot water, and I'll show you that in a second. Okay, and someone's actually taking a shower. I hear the water running. So this water here is going to be slightly cooler than this water. And again, I mentioned that the pump runs 24 hours a day, 7 days a week. So on some outdoor wood burners, the pump at the stove only kicks on when there's a need for hot water to come in from the boiler to the house. So it clears out all the cold water that's been sitting there, and then it leads to longer burn times because it's heating a lot more water. So since my lines always stay hot when there's a call for heat, it may drop at 10 to 20 degrees, but the outdoor wood burner doesn't have to work as hard because there's not a huge fluctuation in temperature between the incoming line and the outgoing line. Alright, hopefully there's enough light. That's what I'm using to heat our domestic hot water. It is just basically a copper plate, a lot of copper plates stacked on top of each other. Okay, this red one coming in from the wood burner flows up. Domestic hot water comes in right there. Ouch, that's hot. And it flows down the copper plates and comes back out here, and that flows into the top of the hot water tank. Then it just stores here unless someone's using hot water. Then it flows out to the hot water in the sinks, hot water in the showers, or whatever. This hot water tank The estimated average electricity used, or cost, I should say cost, is $508 a year. That's how much on average, you know, we take a lot of showers, we do a lot of laundry, and we do a lot of dishes. So we're constantly using hot water. So where this is the estimated yearly cost, I would assume that my household is probably slightly higher than that, or maybe significantly higher than that. So we eliminate spending money on heating hot water by electricity because we're using this copper heat exchanger. All right. So again, here comes this hot water coming in, and it flows up. It exits out the top here, and we're going to look. So it comes out the top of the hot water. It comes out of the hot water block, flows across this pipe, and comes down to here. All right. I'll talk about this section here in a second. That's a manual bypass for the summertime. It's not summer, it's winter here. So the hot water flows in, and it goes into my plenum. So this is my actual heat pump, you know, central air. So in here, I'm not sure if it's here or below, probably below, down here somewhere. There's a blower motor that kicks the fan on. The air goes up, and basically there's like a radiator sitting in there now. And the hot water goes into that radiator, goes through all the coils or whatever, and comes back out on this other side. So when we need heat in the house, the thermostat senses that. Let's say if it's 74, we have it set on 74, and the house drops to 73. It tells the blower motor in here to kick on, and then it blows cool air through the radiator or heat exchanger, and then it goes out to the house as hot air. So then it comes out the blue line there, and it goes back outside. All right, now back to this T, okay? If I close this lever down, you know, close this so hot water can't flow there, and close that side, right? That prevents hot water from entering the ductwork here in the summertime, because if you're running your AC, you don't want a bunch of hot air or a hot, you know, 155 degree water setting there as you run your AC. So we put in a manual bypass. So we just close these levers, then the water can't get no farther than right there where you turn it off. So in that case, since I burn year round, it comes from the hot water block over there. It comes over and comes down. It crosses over without going into the ductwork and comes back down and out. And basically, that's how we heat the house and the hot water. Now, our electric bill was running, we're an all-electric house, keep that in mind, and 1,800 square feet upstairs, 1,800 square feet in the basement. We were having electric bills in the winter north of $400. Never seen 500, but always in the 400s. After I installed this system, which the system was probably 7,000 and some odds and ends here and there for extra shark bite fittings or whatever the case may be. You know, so that maybe about 7,000 and a few $100. I'm not quite sure, didn't really pay attention. It was just something that I wanted to do. We went from the 400 plus electric bills, so I do know one was like, let's say 436, okay? Then we went down to like 150 in the winter, 136 in the winter, 140 in the winter. So we clipped our electric bill in the winter by over $300. That's pretty substantial. And again, that's obviously a portion of the hot water tank and heating the house. Now, you have to value your time. And when I say that, when you're thinking about return on this system that you've installed, if you just love to cut firewood and you don't want to place a value on your time, I don't think you're doing yourself any justice. At a minimum, you know, I would think that your time is worth $10 an hour doing hard physical labor like cutting firewood and splitting firewood. So realistically, if you start taking that into consideration, it may take longer for your return on investment. Now, I can buy 2 cords of wood for 150 bucks. And again, that impacts the return on the investment for this heater eventually paying for itself. The comfort factor, I think we decided that we would assign about $100 a month in the winter as a comfort factor, because those of you with an all-electric house, you know, in the winter with just a heat pump, you're freezing. You know, it blows out cold air all the time. Now, when you walk by a register and the heat is on, you can feel hot air coming out of the register. So our comfort factor, you know, we put a value on that. You know, I've looked at the 3 years worth of electric bills, and I can tell the difference between the previous winters and the winters now with the system installed, which I've been burning for 2 winters now. It's pretty good. I'm really impressed. My only regret is not buying this system as soon as the house was built and then having it up and running. Let's see, we've been in the house 11 years now. I'm guessing if I installed that system 11 years ago, it would already paid for itself. But nonetheless, you live and learn. So I hope this video can help some other people out. You know, if you're wanting to cut your electric bill and you're willing to cut firewood, this is a good way to do it on an all-electric house. As always, thanks for watching.